Hello everybody, welcome back. Today we're going to finish 5.5. We'll be starting at example 3 and finishing with example 4. Example 3 says determining the domain and range of the graph of a situation. This graph shows the number of fishing boats, N, anchored in an inlet in the Queen Charlotte Islands as a function of time. A, identify the dependent and independent variable. So the independent variable, if you're given a graph, the independent variable is always on the horizontal or the x-axis. And of course, like I mentioned in the earlier video, it would be time. Okay? So the independent variable is time, t. The dependent variable is number of boats, and that's given by n. Okay? Red, unbold that, italicize my variables. And that's it. Okay? So remember, the number of boats depends on the time of day. Okay? And if we have a graph, your independent variable is on the horizontal or the x-axis, and your dependent variable is on the vertical or the y-axis. Why are the points on the graph not connected? This is a great question. Well, the points on the graph are not connected because the number of boats is restricted to a whole number. You can't have a half a boat, you can't have a quarter of a boat. This means that most values between the points are not valid. For example, between 10 and 11, the number of boats decreases from 10 to 8. We may point a plot at 9, if we know a corresponding time, but there's no other value that's valid between 10 and 8 other than 9. Okay? So you have to sometimes look at both variables, x and y, to determine that relationship. Okay? Next is the domain and range. So when you have discrete data, you will write unlike the last example, your domain and range is just going to be as the points that you see. Okay, so as you'll see here in a minute as we plot the domain and range, or write the domain and range, sorry, from the graph. So what we normally do is we'll look at our coordinates. So we have 1, 2, 3, 4, 5, 6, 7, 8 different times. So we're going to write those in, and we'll order from left to right. Okay, so we have 9. And I assume you'll notice that it says 1700, so that it would be 9 a.m., but we don't need to put a.m. or p.m. because it's in 24-hour clock, right? So 1700 hours, or 17, means 5 p.m., okay? If you're not aware of that. The next one was at 10, 11, 12, 13, 14, 15, 16. So all of the points are at right on the hour is where they were. Okay. So we have 11, 12, 13, 13, 14, 15, 16, and 17. And then we close our brackets, the braces they call it. So we have 1, 2, 3, 4, 5, 6, 7, 8. Did I do one twice? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there was no 1700. My apologies. Okay, I just saw it there, but it only goes to 16, 4 o'clock. Okay, in the range, we'll do the same thing. All right, and the range, we'll start at the bottom here, and we'll go up. Again, if something's there twice, there's no need to put it twice. So, for example, there's number of boats is there 6, so we don't need to put 6 twice, we just put 6. And the next highest one up is 8. And the next highest one up is 10, and there's 2 there, but we don't need to indicate that. Then there's one at 11, and then there's one at 15, and then there's one way up at 25. Okay? So those are the all the values for the range. Again, 6 was there twice, and 10 was there twice, but there's no need to indicate that, so we only have 6 values in this case because 6 is twice. All right. So this is actually a function, though. Don't get confused. It's only vertically if it's not a function. Horizontal's fine, because this is 10 o'clock and there's had to be 10 boats, and at 2 p.m. or 1400 hours, it also has 10 boats. So this is a function. Don't be confused by that. There's a check your understanding you can try with this. The answers are here. Okay. And then we'll go right to example 4. We're given an equation. A function, a linear function. Example 4. Determine domain values and range values from the graph of a function. So here's the graph of a function, f of x. This is what I spoke about before. F of x is equal to negative 3x plus 7. A. Determine the range value when the domain is negative 2. So there's a couple ways you could do this. Because we have the graph right in front of us, we can literally just go up and look at the value here, and we can see that it would be exactly 13, okay, for x. But we can do that as well as solving that into our equation. So there's a couple of ways you can approach that, right? So there's 2 ways. I'll show both. Obviously, just looking at the point, the coordinate. So when x is equal to negative 2, y is equal to 13. Right? You could clearly just say that if you wish. If you wish. And what we're going to do, I might as well do it now, and when we're going to solve for that, you would, because you're given the function, you can just take your equation, f of x equals that value, and then you could literally just plug the value in. So, let me get that right again, my apologies. So f at negative 2, so we substitute our value in for x, right? Everywhere you see x, you're going to put negative 2, right? Oh, negative 2, so negative 2 times 3 is 6, all right? And 6 plus 7 is indeed 13, we got to that. So you could have obtained that value from the graph, or you could plug it into your function for your graph and solve for that as well. Determine the domain value when the range is 4. So if the y value is 4, the x value is 1. So we can say, we can do the same. So I'm going to copy all this and we'll rewrite it. So when y is equal to 4, x is equal to negative 1. You can clearly see that it's negative 1. Okay, from your graph right here. Or sorry, positive 1, my apologies. 4 is 1. Okay, sorry about that. We can also do it with our function as well. So if it says the range value is 4, f of x is the same as equivalent to y. So that means that our f of x value, the whole value is equal to 4. Okay? And then we just solve for x. So next step would be, you're going to subtract 7 from both sides. Right? So we subtract 7 from both sides. Subtract 7. 7 subtract 7 is gone. That leaves you with 4 subtract 7, which is negative 3. Now, the next step is to divide both sides by, negative 3. By both sides by negative 3. The negative 3's will divide. Giving you 1, and negative 3 divided by negative 3 is indeed, like we mentioned before, 1. X is equal to 1. And you can switch the sides. Okay? Negative 1. Negative 3 divided by negative 3 is 1. Alright? Check your understanding that goes with that, and you guys can work on that. Okay? The answers are there for the check your understanding. The homework for this particular section, 5.5, is going to be page 294, number 7 through 10, 13, 16, and 17. All right. You could also, we'll probably look a little more in domain and range another time, but for now, you can work on those questions. Thank you, everybody, and we'll see you in the next video. 5.6, properties of linear relationships. Thanks, everybody, and have a great day.